Red Hat is known by many of our customers as their key partner in being able to exploit open source technologies and be able to drive those open source technologies to meet critical enterprise business needs. The classic example is Linux. Red Hat Enterprise Linux allows people to deploy a wide range of mission-critical applications in the enterprise data center. One of the important aspects of the Red Hat Enterprise Linux ecosystem is really a strong partner ecosystem. This includes partners that are platform vendors. This is partners in both at a storage component level and a standalone storage level and a very large ISV portfolio. Within this context, LSI is a valued partner, particularly because they're doing work at the silicon and semiconductor level, and then really allowing us to deliver incremental value both in terms of cost and capabilities to our customers. Now, in the case of Syncro, what LSI has been able to do is take what was previously a higher-end technology, standalone RAID, and be able to combine both the volume economics of RAID on a chip controllers with the volume economics of very low-cost SAS switches and be able to bring to users the previously high-end technology at a volume economics price. The value for Red Hat, really for our customers in storage, is it allows us to take a very typical approach of software-defined storage, where you either take an individual element and for high availability, replicate it 3 ways. So if an individual disk fails, you still have a copy of the data. Or what we typically do with our Red Hat storage technology, replicate 2 ways with then a very low-cost RAID on a chip. But by Syncro, rather than maintaining 2 copies of the data and then the cost of the disks, we're able to have a single copy of that data. What has typically been a multiplier of 2.4 to 3 times usable storage to what you have to acquire allows us to bring that into 1.2, so substantial cost savings for our customers. This technology will allow us to have lower cost offerings for classic HA enabled by both RHEL and the RHEL HA failover technology. We actually see a few use cases. One is the classic cloud data center. This is someone deploying either leading-edge applications such as OpenStack or big data applications such as Hadoop. Syncro will allow us to take, for example, 64 nodes, structure them as 32 pairs of nodes, where each node both delivers its data but can serve as a hot standby of additional data, therefore providing high availability. That ability to be able to deliver high availability without having to buy the disk twice is really a compelling aspect of software-defined storage. Another use case that we've been considering is distributed branch offices. This is a slightly different example where the desire is to be able to have some local computing, but be able to do so at the smallest possible footprint. So this is an interesting example where we can combine Red Hat's virtualization technology, RHEL KVM, delivered in, for example, Red Hat's enterprise virtualization technology. We can host on top of that our Red Hat storage software-defined storage technology, and below that, in a 2-node configuration, very low-cost storage. So what that allows us to do in a very small footprint is have high availability virtualization, high availability storage, and yet have both only 2 servers and a very small amount of storage. So it's very cost effective for branch office configurations such as banks, retail stores, and others. The combination of the underpinning of Red Hat Enterprise Linux, its support with LSI Syncro, really combines the scaling capability, our replication capability, and then the very low-cost mechanism for persisting individual elements of storage to allow us to really deliver breakthrough economics for storage.